simultaneously. So because there will be some repulsion in the negative charge. Hello everyone, welcome back to Plutus STEM. Today we are going to discuss elimination reaction of alkyl halides. So we have already discussed the substitution reaction of alkyl halide, in which we have discussed the various reactions in which the substitution of alkyl halide with various different substituent was taken place. And today we will be seeing another type of reaction, that is elimination reaction of these alkyl halides. So those who are not that much familiar about these elimination reaction, we can move on to this YouTube link provided below regarding this elimination reaction of class 11. You can go through that videos and you will be having a great idea about what are E1 reaction, E2 reaction, E1CB, and when they are proceeding, when this SN will take place, when the E1 will take place. So all those things have been discussed in that quite detail in the class 11th only. So we will just have a quick review about that. So generally we are having three type of reaction: E1, E2, and generally E1CB over here. So so firstly we will be discussing regarding this E1 reaction. So they are very much familiar to the SN1 reaction. Those the conditions which are taking in SN1 reaction, same type of things we are going to take generally in E1 reaction. And the main thing which we are going to take over here will be higher temperature. If the temperature is high, if we are given with a higher temperature, then we are going to have more product of this elimination reaction, and the lesser product of a, you can say, SN1 reaction. In the same way, all the conditions that are present in E2 reaction generally. So just if we are seeing the higher temperature, then we will be seeing over there that E2 is going to follow in competition to SN2. So these are just two major difference. So we will see all these things in quite detail when we will be seeing this further reactions. So these are like alkyl halide. If we are having this alkyl halide and it react with some you can say KOH, or you can say if the KOH is there, then we are going to have SN2 type of reaction. If we are having simple water as a reagent, ROH, CH3OH, so like if we are having CH3OH, or you can say weak base type reagent, CH3OH, or you can say ROH, or you can say water. If we are having these type of reagent, if they are coming into the place, so these are being termed as weak bases. So in this case, we know that we follow the SN1 reaction generally. But if we are putting some heat also there, which means some high temperature nearly 50 degree or above, so what we are going to visualize over here, that this is Rx. Here we will get a product like this. If we represent this in a better way, see like this. So this is a better representation to show this. So over here, how this elimination takes place. So in this weak bases, so what happens over here are the polar protic solvent. We are having generally the polar protic solvent, and these are always can work as a solvent also. These can work as a polar protic solvent. So what they are going to do, they will initiate this reaction. They will link with this reaction and this polar bond, partial positive charge and partial negative charge. This it will initiate to break down, and we are going to have this X outside, and after that this X is being removed, and this X will be blocked by the various polar protic solvent. So these various polar protic solvent, what they are going to do over here, that we will be seeing that this is being trapped over here. This is going to be trapped in this chain. This X negative is going to be trapped like this. So now if you see in the above slide, so how this reaction follows, H, this X. So in the first step, that is also a rate determining step. This is the even we are going to follow such type of thing. This is going to leave from here. In the first step, we are going to get a carbocation, positive moiety CH2, as like this. So now this is a carbocation, and we need to have a more stable carbocation formation is going to take place over here. So we need to have a more stable carbocation. So this is the condition. If rearrangement is possible, so there will be a place of rearrangement also. If there is a possibility that some rearrangement can take place, then you will see over there that rearrangement will also take place. So in this case, now this base will abstract this, you can say, this proton from here. This proton can be abstracted by this polar protic solvent, and this bond come over here, and we will get a product CS2 double bond CS2. Formation of alkene. We will see the formation of alkene. So this is the general reaction, how this reaction is going to follow over here. If we are having a product like this RCH single bond CH2, RCH single bond CH2, over here Br and over here CS3. So if this is our reagent over here, so now if we see, so what are the possibilities now? In the first step, what will happen? In the first step, this is going to leave out from here. If we are providing heat also, and ROH or H2O, whatever with the solvent and reagent we are taking, so this will be proceed like this RCH2 single bond CH single bond CH3, a carbocation over here. So after that, what happens over here? This base will take the proton from two sides. Now earlier case we were having only one possibility. Now we are having two possibilities. So in these two possibility, what is going to happen over here? From these two possibilities of the beta position, these two possibilities at the beta position, this will take, the product will be like two type. If it follows the one first hydrogen is being taken, then we are going to have a product like RCH double bond CS3. And if we are following through the second pathway, this second pathway, then we are going to have a product R single bond CH2 CH double bond CH2. So this will be the product over here. So two different products are there. So this is less stable, and it is also termed as Hofmann product. This product is also termed as Hofmann product, and this is more stable, and that is termed as Zaitsev product. And this is produced in a more quantity, or you can say the higher quantity. So that proton will be abstracted, which is giving us more stable product, or you can say the Zaitsev product. And this is the alkene. This also occur in two forms. One, it can be like cis, another it can be like trans. And we know the trans is more in yield. If we compare this product also, in this also trans will be in the major portion and cis will be in the minor portion. These two are combinedly are also known as Zaitsev product. This is Zaitsev, and these are two part of this Zaitsev product. So this is the way how this even mechanism, when we are taking some polar weak nucleophile, or you can say weak base, then such type of reaction in presence of heat, we are following the even mechanism. So if we are seeing some other possibility, so what is going to happen over here if we are taking some strong bases such as KOH, NaOH, ROH, NH3, NaNH2. So these are like some strong bases. So if the same type of substrate, if we are having RC H double bond CH2, sorry, single bond CH2, Br over here and hydrogen over here. If this type of reagent, when it reacts with KOH, alcoholic, not aqueous. The main thing over here is alcoholic KOH we can take over here, not the aqueous. If you are taking the aqueous KOH, then the possibility is some addition reaction is possible. So we have to take the alcoholic KOH or alcoholic NaOH, or we can say take NaNH2, very strong base. NaNH2, NH3. So this type of bases we can take NaNH2 in presence of NH3. So these type of bases are very strong bases. So this type of base, when we are taking the in presence of heat, then E2 elimination takes place. Then what is going to happen? E2 elimination will take place. In this strong base, what they are going to do? In this case, they are going to follow the E2 mechanism. They are going to follow the E2 mechanism. Why they are following the E2 mechanism? Because this is a strong base. It will not react like in the previous case we have seen. This weak base, it was waiting for this X to be removed. In the first step, it was being removed. Then this weak base attack over here. But in this strong base, it will not wait for the bromine to leave out. It will start attacking. It will attack this. This bond will come over here and this bond is leaving. So simultaneously the whole phenomena takes place, and if we try to draw the transition state of this compound, this will be like C, this bond is remain over there like this only. In product, what we are saying, this bond is breaking of this Br. This new bond is forming, and again this you can say this hydrogen, it is being removing. So it is better if we make it upside. Okay, so this is being forming over here, this hydrogen, and you see over here, this is like this. So this is the like transition state. This is the whole the transition state, and more stable is this transition state, more stable will be the product being formed over there. So this will tell us the which product we are going to get. So this must be more stable, which means it should be more substituted. If the substrate is more substituted, then we are going to get more stable alkene, and that is the Zaitsev alkene. So in such type of reagent, we are taking KOH, NaOH, NaS2. This base is being taken. So and with the one thing, because one bond is going, another bond is breaking. So this Br is coming or base is coming simultaneously. So because there will be some repulsion in the negative charge, that why it's try to come from the back side. So generally over here, anti-elimination takes place. In such type of reaction, we are going to see the general reaction which we are going to see over here will be like anti-elimination is going to take place over here. In such type of reaction, we will be seeing anti-elimination will take place over here. Generally, we will be seeing that anti-elimination will take place, and the product which we are going to get over here. First, I will draw over here only. That would be better. Okay. So we will get a product like RCH double bond CH2. So this is like the product we are going to get over here. So if we take an unsymmetrical alkene, if we are taking some more example of some asymmetric alkene, so what type of product we are going to get over here? In this, if we are having this alkene, this is a simple alkene. So if we are taking you can say alcoholic KOH in presence of heat. So what will happen over here? So this is bromine that is going to be leaved out from here, and over here we are having 3 hydrogen at beta position. Okay, so from here it will take the hydrogen from here, and this bond will come at this side, and this is going to be leave. Okay, and we are going to get CH2 double bond CH2. So this is going to be our product. So this type of alkene we are not having, two possibilities we are not having. But if we are having some longer chain, if we are having such type of moiety, which means some longer chain we are having. So if we are having such type of moiety, so then what is going to happen over here? Or let's say this one. This is our moiety, and we are taking now alcoholic COH in presence of heat. If alcoholic COH, KOH in presence of heat, we are planning the reaction. So what will happen? This is going to leave out. So now two possibilities are there: hydrogen at this side and hydrogen at this side. So we are going to get two type of product now. One will be like this if we are taking hydrogen from this side, this plus this. So these are termed as Zaitsev product, or you can say more stable product. And if we are taking the hydrogen from this side, this is the one pathway. The second pathway, the product which we are going to get over here will be nearly from this carbon over here like this, and this will be leaving out from here. So we will be getting a product like this. So this product is Hofmann product. Hofmann product, or you can say less stable product, or you can say these are going to be our minor product. So these are going to be our minor product. So one or two more important things: if we are having a very strong base such as NaNH2 in presence of ammonia, so it can also take Br hydrogen. If we are having such type of moiety, then also it can take, because it is very strong base, so it will take the electron proton from this also, which means sp2 hybridized vinyl position. So we are going to get, at in presence of heat, the product which we are going to get over here will be C triple bond CH linear. So this is the product, which means if this is a very strong base, so it can also take the proton from vinylic position. So like other bases such as alcoholic COH, alcoholic NaOH, so they are not that much capable to take the proton from this position. So that's why this is like a very important reagent when we are going to take some higher way where we need to take the proton from that side, that is not that much reactive, or you can say that much feasible. So we can take a strong base over here and we can take a good product. So now one more thing, that anti-elimination I have told you. So they proceed through the anti-elimination. So if we take few example of this, how this anti-elimination is being taken place over here. So if we are having this cyclic compound CH3 over here, upper side, so we know that hydrogen will be below side. Over here we are having chlorine upside, hydrogen below side. At this side we are having hydrogen upside, CH3 below side. So in such type of reaction, the base is going to base and heat. So which type of reaction we are expecting over here? If you are not familiar, so you can take that this can also be abstracted and this can also be abstracted. But the main thing which I told you, this base will come on that side, that is less hindered. So in this case, this is the reagent. Here we are having hydrogen. At this position we are having chlorine. At this position we are having CH3. So this Cl we want to leave. So it will take this hydrogen, it cannot take this hydrogen. It will take the hydrogen that is below side. So hydrogen from the below side, this one will be extracted. Less hindered from the below side. So this hydrogen will be extracted and this Cl will be used anti-elimination. This will proceed through the anti-elimination. So the product which we are going to get over here will be a bit like this. CS3 and this CS3 below side will remain like this. So this is the product which we are going to get over here, not this one. So this should be this proton and chlorine or the leaving group should be anti to each other. These two groups should be anti to each other, then only we are going to get a better product. So one more important thing is, if we are taking some bulky bases, if we take some bulky bases, so if we are having a methyl, ethyl, propyl, butyl oxide, sodium butyl oxide type of a base if we are taking, so this type of base they can take cannot take the proton from hindered reagent. Hindered base it cannot take. It will take those bases only that are present on the less hindered side. So if we take an example of this, so we are having CS3, CH, CH, CS3, CS3 and a Cl at this side. And we are reacting with this O negative base in presence of heat. So what it will do? So there are two possibilities. So from us, if we are taking the proton from this hydrogen that is more hindered by this CS3 and CS3, so we are going to get a more stable product, that will be CS3, CH, the single bond, CS3, CS3, this product. And another way is like, if we are taking a base is taking this side, that is, oh sorry, if this base is okay, if this base is taking this proton, so what will happen over here? We will get a product like this: CH2 double bond, CH single bond, CH, CS3 and CS3. So this one is an Hofmann product. This one is Hofmann and less stable. And this one is Zaitsev, more stable. But due to this bulkiness of this group is quite bulky, so it cannot take the proton from this inside. This inside proton, this strong base, you can say bulky base, is unable to take the proton from this less more hindered side, so it will preferentially take the proton from less hindered side only. So this is going to be the major product. In this case, this is going to be the major, and this one Saytzeff product is going to be the minor product. So this is very important example we are going to see over here. This is the minor product and this one is going to be the major product, that is Hofmann or less stable. Hofmann also less stable also, but is major because this bulky base is unable to take proton from that side, that is giving us a more stable, you can say, alkene. So now we will be quick review of quickly revise all these things. We have told you that there are three types of reaction. So E1, E2, E1CB. So then we try to discuss firstly regarding the E1 reaction. In this E1 reaction, I have told you that some weak bases are being taken in presence of heat. So to complete this reaction more towards the elimination. So this first in the first step, X, or you can say leaving group is going to leave from here, and we are getting a carbocation. If rearrangement is possible, then rearrangement also takes place, and we are going to get a alkene. And in the second step, we are going to see over here, we are having this alkane in heat. Again the same example. So the more stable Saytzeff product is being produced, and in this more stable also cis trans, we are going to get trans stable for more in yield as compared to cis form. So regarding the E2 elimination, we need to have a strong basis like KOH, NaOH and ROH, or NaNH2, some more strong bases, alkoxide base. So these are being needed to take place this E2 reaction in presence of heat. The heat is a very necessary condition for elimination reaction, and again this proceed through a transition step or a single one step reaction. It is a one step reaction, and this reaction is being followed. You can see over here, firstly the proton and bromine both are being coming and leaving simultaneously at a. So now we again the Saytzeff is going to be the major product most of the time, and Hofmann is going to be the minor product. And we have I've told you that this reaction generally follow the anti-elimination. The hydrogen and the halogen, leaving halogen should be opposite to each other. And now we have discussed this very important example and testing where the syn elimination is not preferentially taken place as compared to this anti-elimination. Though that hydrogen that is anti to Cl is being abstracted by this base, and we are getting this one as a major product. So I have also told about sometime we also get a Hofmann as a major product when we are having a bulky base like alkoxide ion. Over here sodium alkoxide we have seen. So this type of Hofmann can also give a major product. So that we have discussed in this that how these reactions are being followed. So in the previous we have discussed regarding the substitution reaction of this alkene, and now we have discussed regarding this elimination reaction of this alkene. In the next video we are going to discuss regarding the various reaction with metals of these alkyl halide. So if you want to continue with that, so you need to proceed. We will be in the next video we will be discussing the reaction with different metals like sodium, magnesium, copper, and we are going to synthesize the various interesting reagents such as Grignard reagent, Ullmann reagent. So many more things we are going to see in the next upcoming lecture. So be continued with this series. Thank you. Have a nice day.